exists for x, so for 1 over x.
Exactly. Brilliant. So this was very clearly stated from the get-go. If this is not a number, and if this is not a number, one or both, the limit property or law cannot be applied. So this cannot be, this side cannot equal that side. Perfect. Okay, next limit law, number 2. And allow me to put these two together and just add the minus here. That's how lazy people do it. So if it's plus here, of course it's plus here. If it's minus here, of course it's correct, the same order. So the limit of a sum is the sum of the limits, assuming the limits exist. The difference, the limit of a difference is the difference of the limits, assuming the limits exist. Okay, the next one. Limit of f of x times g of x as x approaches a. What do you think this equals to? A wild guess.
F of g.
So limit of f of x as x approaches a multiplied by limit of g of x as x approaches a. Is this okay? So this equals to what?
L.
Very good. And the other one times m. Perfect. So that's number 2. Number 3. Limit of f of x over g of x as x approaches a from either side. What do you think? Wild guess.
The limit of f of x as x approaches a divided by the limit of g of x as x approaches a.
Excellent. Good. And then
L divided by m.
I have not had this before, comma, only if what?
M is not equal to 0.
Or the limit of this does not equal 0. Very good. Number 4. Limit as x approaches a from a constant c. What do you think? Wild guess.
C.
That's it. Who cares where x is going? A constant is a constant. Very good. Number 5. Limit of a constant times f of x as x approaches a. The constant is a factor. It could go in front. So this is c times limit of f of x as x approaches a, which will end up being c times L. Number 6. Limit of f of x raised to a power n as x approaches a. We call this the swapping of the operators. Swapping operators. What does that mean? This has to be applied first as an operator to f. And then the second, I'm going to swap them. And they will be applied in the opposite order. Meaning, I will put limit first, limit of f of x, and the answer is raised to power n as x approaches a, which turns into L raised to power n. Of course, n is an integer. We have the same thing with the nth root. So let's put them in the same, or you can call this one 7, it's up to you. So the nth root of f of x Of course, n has to, if n is even, then the function around a has to be positive. So again, the swapping of the operators. This normally is applied first and then the second. This is the second one. But now we're going to swap them. We're going to apply the limit first. And we have this, the nth root of L. Any questions on this? Okay, I want to add here number 8, the limit of a polynomial. Oh, I didn't mean to write that. Sorry. It's a y here. Oops. Polynomial equals, as x approaches a, equals the polynomial function at a. So if I want to find the limit of x squared plus 2x minus 1 as x approaches 0, all I have to do is plug it in. That's what this theorem says. 0, 0, negative 1. But there is a problem here. Because remember, a few minutes ago, maybe half an hour ago, I said when x approaches 0, this automatically means what? That x anyone?
Is undefined.
Does not equal 0. But here I am telling you to plug in 0. So this is a contradiction. When x approaches 0, I specified clearly x does not equal 0. But yet I'm telling you to plug it in. And this is a theorem. It happens that it is true. So all you have to do, if you are determining the limit of a polynomial, we just plug it in. Same thing with the limit. So if you want number 9, of a rational function. So the limit of a rational function, same thing, f of a. Only if a is in the domain, of f of x. If it isn't, I cannot plug it in. It means that I have to find another way to find the limit. Okay, so let's look, before we talk about continuity, I would like to stop and look at some problems. So I want to go to page 113. 113. I have not heard from everyone today, so I'm hoping that I will hear from everyone next time. Okay, so I like to choose from 9 through 18 first.
Can we do 16?
16 it is, very good. And I'm on page 7. I'm going to copy it and I'll stop sharing. You said 17? No, you said 16.
Yeah, 16.
16, very good. Okay, 16. Limit, let me copy it. As x approaches negative 1, from 3x to the 5th plus 4x to the 4th minus 3x plus 6. And I'm also going to copy 17 as well. Limit as x approaches 3 from x squared minus 25 divided by x squared minus 5. Okay, perfect. So we just wrote the last two theorems here. If this is a polynomial, all I have to do is plug in a in the polynomial. So this is a polynomial. What is the degree of this polynomial?
5.
5. Perfect. So all I have to do is just plug it in. I drop the limit operator because I already plug it in. So 3 Negative 1 to the 5th plus 4, negative 1 to the 4th minus 3 times negative 1 plus 6, and I perform the calculations. This is 4, this is negative 3, so that's 1, plus 6 is 7, plus 3 is 10. Same thing here. Is 3 in the domain of this function? Because if 3 is not in the domain of this function, I am not allowed to use this theorem. Because it says only if A is in the domain of the function. So that's the only thing. This is a rational function. I need to verify whether 3 is in the domain. If 3 is in the domain, I plug it in and it's done.
Yes, 3 is in the domain.
3 is in the domain. Very good. So then the numerator, we can go ahead. We drop the limit operator because we plug it in. So I have 9 minus 25 divided by 9 minus 5. Good. So then the numerator, I think it's negative 16. And the denominator, I think, is 4. So the answer is negative 4. And that's it. So these were simple examples in which we were determining the limit of a polynomial when x approaches negative 1 and the limit of a rational function where 3 was in the domain. Very simple, just plug it in. The last two laws or theorems. Okay. Good. I would like us to choose from 19 through 30. We're not going to be able to finish this section today. We only have, I think we have 4 minutes left. So the
20.
second half, forgive me, sorry, I'm ready.
We can do number 20.
20, very good. So we have limit x squared minus 25 divided by x minus 5 when x approaches 5 from either side. Okay, I'm going to stop sharing. Perfect, Vic. So we see that this is a rational function, a ratio of two polynomials. Perfect. So every time, so this is another note that I don't want to forget. Let me write it now. Which, again, it will sound like a contradiction. When determining a limit, we must plug A, this one. This is the A in first. In order to examine, find if you want, the type of limit. We are facing. Same thing here. I specifically said x approaches negative 1. X does not equal negative 1. But I have to plug it in because it's a polynomial and I know this will give me the answer. There is a theorem that supports that. Same thing here. X approaches 3, but I'm not allowed to plug in 3 because x cannot be 3. But it turns out that there is a theorem that allows me to do that. Here I have to see the type of the type of limit this is. So please plug in 5 at the top and 5 in the denominator.
It would make the denominator 0.
Good. What else?
And the numerator 0.
Ah, there is hope. No guarantee, but the limit may exist. Good. So what will you do next? What do you think we should do next? And we discussed this on the first day of classes.
Factor the numerator.
Excellent. That's why we review those 3. Good. So what do I have to write then?
X plus 5.
X plus 5.
Excellent. Great job. Of course, what do you think I'm going to do next? Obvious thing.
Simplify.
Now, please plug in the 5. You drop the limit operator. This is another note. Do not drop the limit operator before the last Very last step. Good, so what is the answer then?
10.
That's it.